Okay, so this is part 2 of electron configurations, and I want to talk about doing electron configurations for transition elements and also how to write shorthand. And we're going to do transition elements first because it's going to show us why we need that shorthand. Okay, so let's look at chromium, for example. Okay, now, remember when we do electron configurations that we start at the very beginning and we just keep going through every period until we get to the element we want. Okay, now, I'm going to start in period 1, the S block, and there's 2 squares in the S block, so I would write 1s2. Still haven't gotten to chromium, have to keep going. Now I'm in period 2, S block, and I go 2 squares, so I write 2s2. Still haven't gotten there. Now I'm in period 2, the P block, and I have to go 1, 2, 3, 4, 5, 6 squares. So that means there are 6 electrons in the 2 P orbitals. Still haven't gotten there, have to keep going. Period 3, S block, 2 squares. Still not there. Still in period 3, P block, 1, 2, 3, 4, 5, 6 squares. Still not there. Down here, period 4, S block, I go 2 squares. Okay, so this is the first time we're encountering the D block. Now, there's an exception you need to know about the D block, and I'm explaining why in class, but for now what I want you to know is that when we're in period 4, we're filling the 3 D orbitals. So the D orbitals are basically, they're one period lower than you would expect based on their energy level. So in period 4, these are the 3D orbitals. In period 5, these are the 4D orbitals. In period 6, these would be the 5D orbitals, and so on and so forth. We're really only going to talk about period 4 in this class, as far as electron configurations go. So basically what you need to know is that yes, this is period 4, but these are actually the 3D orbitals that are being filled. And again, we'll talk about why in class. It has to do with the relative energies of the orbitals when they're empty and full, but they are technically in the 3rd energy level. So now I'm in the 3D orbitals and I'm looking at chromium. So then I have to count 1, 2, 3, 4. So I would write 3d4. Okay? Now, this is obnoxious, right? That is really long to write, and it doesn't seem like we should really need to write all that much. It seems like there must be a shorter way, and there is. It's called shorthand configuration. So, with shorthand configuration, what we do is we take the noble gas that we went past most recently, so in this case argon, and we start by writing argon in brackets. What that means, that argon in brackets represents the entire electron configuration of argon. So in this case, that would be 1s2, 2s2, 2p6, 3s2, 3p6. So instead of writing all that, we just write that. And everybody knows, okay, that's all of that stuff right there. Now, why do we use noble gases? Because they have full outer energy levels. So basically, it's like saying we've done the whole first 3 rows, and now what comes after that? So then I would put argon in brackets and say, okay, now I keep going after that. I'm in period 4, the S block, and I go 2 squares. Remember, these are the 3D orbitals. Period 3, well, energy level 3, D block, 4 squares. Okay, much, much, much faster. All right, so I'm going to do another example of the shorthand configuration. Let's say for, I'm going to do something in the next period just for fun. All right, so let's say of zirconium. Okay, writing the full configuration of that would just take forever. And it's not necessary, right? So I look back. The most recent noble gas was krypton. So I'd write krypton. Now I come down here. What period am I in? Period 5. This is the S block, and I go 1, 2 squares. Now remember, these are the 4D orbitals. So period, well, energy level 4, D block, and to get to zirconium, I go 2 squares. Okay, so this is a lot faster. Generally, I don't care which one you use. It's sort of your preference unless I specify that you must use full or you must use shorthand. You should know how to do both. Okay, let me know if you have any questions. Really, this 3D thing in period 4 is just an exception that you need to know. And so you just have to make sure that you're being careful anytime you're in the D block to remember that.